we consider our general cubic, y is equal to ax cubed plus bx squared plus cx plus d. The most important term in terms of large values of x is the x cubed, and therefore the value of a is of crucial importance in determining what happens to the curve at the extremities. If a is a positive number, then if x is positive, we will have a positive value for ax cubed, and when x is very large, this will completely override the other terms in the expression. So therefore, the curve must be positive for large positive values of x. The implication this will have on the shape is that the curve must go off of the top in the first quadrant. It must also go off of the bottom in the third quadrant, because when x is negative, x cubed will be negative, and then multiplying by a positive number will give a negative number, and since the x cubed term is always going to be the largest for large positive or negative values of x, this will be the largest term and therefore will override the others. So if a is positive, the curve must go off of the bottom in quadrant 3 and off of the top in quadrant 1. And if we look at these curves, this one and this one obey that rule, and we can identify these as ones where the coefficient of x cubed is positive. We can apply the same argument to the situation where a is negative. The x cubed term must dominate, so if x is positive, this term will be negative, and if x is negative, the term will be positive. And the effect this will have on the graph is that the curve must go out of the bottom in quadrant 4 and out of the top in quadrant 2. And the curves we have here, we can identify this one and this one as obeying this rule. So we should identify the coefficient of x cubed is negative for these curves.